Let's talk about adding and subtracting radical expressions. In order to add or subtract with radicals, everything about the radical must be the same. You have to have the same radicand, that's the stuff that's under the radical, and you must have the same index, so they have to be the same type of root. For example, the one that is here, since they are both square roots of 2 that we're trying to add together, they have the same index, both are square roots, and they have the same radicand. The number under the radical is 2 for both of these. So since they are exactly the same radical, we can combine the numbers out in front. 5 plus 3 gives us 8 of the square roots of 2. Everything about the radical was the same, so we were able to add those together. In our second example, 5 square root of 2 plus 3 cube root of 2, they have the same radicands, but they are different when it comes to the index. Since the indices are different, we cannot add these together, and there is no more simplifying than when the problem began. We have to leave it right here. Likewise, with the third example, 5 square root of 2 plus 3 square root of 3, while they have the same indices, the radicands are different, and we cannot put these together either. So there is no simplifying further than where the problem began with this one. Sometimes radicals can appear to be different, but they actually end up being the same after you've done some simplifying. For instance, on this one, the first radicand is 2x, the second 50x, and the third 18x. They are all square roots, but they appear to have different radicands. But notice first, everybody here has an x that after we simplify would still be up under the radical. Notice that there is a 2 that is left with this one along with the x. So if I'm going to be able to add or subtract anything with this, I'll need to have a 2x left under the radical. Does 2 go into 50 and give us a perfect square in addition to it? It does. 50, if you divide by 2, goes 25 times, and notice that 25 is a perfect square that can be simplified. Same thing back here. 2 goes into 18 9 times, and 9 is a perfect square. It had to go a number of times that would be a perfect square in order for us to be able to simplify the radicals. So let's take this first one and just bring it down since it didn't need any simplifying, and then let's simplify the other two. The square root of this 25 is 5. That 5 times the 6 in front gives us 30. We'll keep the square root of 2 and the x up under the radical. Here on the back, square root of 9 is 3. 3 times negative 4 gives us negative 12. And again, we've got a square root of 2 and of x that we'll keep under that radical. Now everybody is exactly the same square root of 2x. Same index, same radicand, so these can be combined. If we take 10 and add 30, that gives us 40. Then if we subtract 12, we end up with 28 times 2 square root of x. If we have exactly the same radical with the same index and the same radicand, then we can add or subtract. They must be exactly the same radicals with the same index and the same radicand to be able to combine. Sometimes that will involve simplifying to start.